Hi, this is Miss White, and today we're going to be doing lessons 8 and 9. Remember to watch lesson 9 after you are done watching lesson 8. In lesson 8, we are going to be talking about how to represent proportional relationships with equations. So let's look over here real quick. We're going to look at the points to remember. The first one says proportional relationships have a constant ratio or unit rate. Okay. The next one says the constant rate or unit rate of y over x can also be the constant called the constant of proportionality. Okay, so what we really need to remember and why this is important is that the constant ratio or unit rate, these are the same thing. They just have different names. Of y over x can also be called the constant of proportionality. So what we need to really remember is that these are all the same. And what it's telling us is that y over x is called the constant of proportionality. So when we need to find a constant, we are going to use this equation. Okay, we're going to start example 1. Your mother has accelerated onto the interstate beginning a long road trip, and you notice that the low fuel light is on, indicating that there is a half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. You know that if you can determine the amount of gas that her car consumes in a particular number of miles, then you can determine whether or not you can make it to the gas station. All right, so let's circle what we know. Okay, we know that Mom has half a gallon left in the gas tank and that the nearest gas station is 26 miles away. So let's look at Mother's gas record here. When we look at our chart, we know our gallons is going to be our X and our miles driven is going to be our Y. Make sure you have those labeled. Let's look at A. Find the constant of proportionality and explain what it represents in this situation. So when we are trying to find a constant, okay, we are going to label the variable for constant as K. So K equals constant. Okay, and on the last page, the reminders that it was telling us is that our constant, so K, equals Y over X. Okay, so what we're going to do is we're going to take a value from our chart up here and find our constant. So let's use 8 and 224. So we have our constant equals our y, which is 224 over 8. Okay, go ahead and take your calculator out and calculate this. Okay, all right, so 224 divided by 8 gives us 28. Okay, so our constant is 28. If we were going to divide our x's by our y's on this entire chart, they would all equal 28. And that's how we know that is our given constant. All right, B. Write equations that will relate the miles driven to the number of gallons of gas. So what we want to do is set our equation equal to y. So we have y equals our constant times x. Okay, now we already know what our constant is, so we're going to put 28 in for k. So we have y equals 28x. Okay, now let's label our y and our x in here. So our x is gallons and our y is miles. Let's move on to C. Knowing that there is a half a gallon left in the gas tank when the light comes on, will she make it to the nearest gas station? All right, so we are going to use our equation, y equals 28x. So x is the amount of gallons that we have, and Mom only has half a gallon left. So we are going to put half a gallon in for our x. So y equals 28 times 0.5. Okay, go ahead and put that into your calculators. All right, you will see that that will give us 14. So she can only drive 14 miles. Okay. In our equation, it says that she is 26 miles away. Is she going to make it to the gas station? No. So 14 miles is less, is less than 26 miles. So no, she will not make it. Well, that's really not good. All right, D. Using the equation found in part B, determine how far your mother can travel on 18 gallons of gas. Solve the problem in two ways. Once using the constant of proportionality and once using an equation. So first, we are going to use the constant of proportionality. We have our constant of proportionality equation written up here. So we're going to take y equals 28x, and we're going to plug 18 in for our x. So we have y equals 28 times 18. Okay, go ahead and put that into your calculator. Okay, all right, it should give you 504. So she can travel 504 miles. Okay, now we're going to use an equation. Okay, if mom has 18 gallons of gas and she gets 28 miles per gallon, we're going to have 18 times 28. Okay, and again, that will give us 504 miles. E. Using the constant of proportionality and then using the equation found in part B, determine how many gallons of gas would needed to travel 750 miles. So let's do the constant of proportionality first. We're still going to use our equation that we have from B, so that's y equals 28x. And then we are going to plug in our 750 miles for our y. So 750 equals 28x. Okay, now we have to get our x by itself. So to do that, we have to divide 20 by 28 on both sides. I hope you guys have a little bit more room than I do. Okay, I'm going to go ahead and bring this up here. So when we look at our equation, we know that 28 divided by 28 gives us 1. So now we have x by itself. And now we need to figure out what 750 divided by 28 is. Go ahead and do that equation in your calculator. Okay, all right, so you should have gotten 26.8 gallons. When we write our equation, we know that we're traveling 750 miles over our constant, which is 28. So go ahead and use your calculator to calculate this. All right, you would have gotten what we got before, which was 26.8. Ooh, 8 gallons. Moving on to example 2. Andrea is a street artist in New Orleans. She draws caricatures of tourists. People have their portrait drawn and then they come back later to pick it up from her. The graph below shows the relationships between the numbers of portraits she draws and the amount of time and hours she needs to draw the portraits. So here's our graph. Let's label our x and y first. So we have our x as our independent variable and our y as our dependent variable. A. Write several ordered pairs from the graph and explain which each ordered pair means in the context of this graph. So let's look at the blue line on the graph. And you want to see somewhere where the blue line intercepts the vertical and the horizontal lines. Let's look starting at 0, 0. Okay, so the line starts on 0, 0, and we come up here. I see the first intercepting horizontal and vertical line, and that is 2, 3. All right, let's keep going up. 4, 6, and 6, 9. So now it wants us to write it as an ordered pair. So when we write ordered pairs, remember we have our x value first, comma, our y value. So we first are starting off with 0, 0. Then we have 2, 3, 4, 6, and 6, 9. Now let's explain what our ordered pairs mean. Let's look at 2, 3. So 2 and 3 is the ordered pair we're going to label. 3 is the number of pictures, and 2 is the number of hours. B. Write several equations that would relate the number of portraits drawn to the time spent drawing the portraits. So first, we need to find our constant. So we know that our constant equals y over x. Now let's choose an ordered pair and put in our y and our x. So let's use 2, 3 again. So now we have that our constant equals our y, which in this case is 3, over our x, which is 2. When we calculate this on a calculator, 3 divided by 2 will give us 1.5. So 1.5 is our constant. Now let's write another equation. So we have y equals our constant times x. And let's plug in 1.5 for k. So we have y equals 1.5x. When we look at these two equations, they are actually, not that one. They are actually proportional to one another. So they are the same, they are the same equation, because it's proportional. C. Determine the constant of proportionality and explain what it means in this situation. So we already know that our constant is equal to 1.5. So what does this mean about our problem? Well, we already know that k equals y over x, and our portraits are our y. So equals our portraits over our x, which is the hours. So our constant in this case represents how many portraits that can be drawn per hour. All right, students, great job today. Please go ahead and remember you need to watch lesson 9 now.